Well, I will present myself during the presentation. So the theme of today is about a hot topic, artificial intelligence. And it's an approach, I think, that is useful in order to popularize what is AI and how, as a statistician or data scientist or a specialist of the data, we can explain our job, and that our job is not only related to data, but to human. So let's begin. The first question when you meet someone is to ask him who he is. Well, I will give you some clues, and at the end of the presentation, we will understand where I want to go. Well, people often think that what is difficult in job is mathematics or science or computing, but the very, very difficult part of a job, of something we do, is life. We have to manage with uncertainty. We have to manage with many things we can't act on, and all the job is to do our best in order to be good at presenting things. Well, my name is Emmanuel Keita. I am a data boundary spanner. That means I want to use data in order to produce a human-machine continuum for decision making, for decision makers. I live in Rennes. Rennes is a part of France at the left, for the people who know Asterix and Obelix stories. I love poetry, and I give you one here that will be useful for what we will do. I will read it in French. You have the traduction in English below. La nature est un temple où de vivants piliers laissent parfois sortir de confuses paroles. L'homme y passe à travers des forêts de symboles qu'il observe avec des regards familiers. I also love art, and we will see that objects like this one could be very instructive to our imagination. My background is in statistics and business intelligence and things like that. So dealing with data, dealing with human, dealing with computing. And well, I started a company 3 years ago, but I unfortunately had to stop it recently around AI, and especially the topic of business of Bayesian Networks, a specialized field in AI. And well, this is what I do, some things of the last 2 years. I went to Google Zurich for conferences. I contributed to the French strategy report for AI, and I am a lecturer, and I write some articles along, and I contribute to a book that will be edited normally at the end of this month around the principe de précaution, precautionary principle. And I joined Aveyo Consulting as a consultant advisor. As you can see, the topic of my job, or the topic of data in general, is very wide. It goes from cybersecurity to politics, to lectures for students for various fields, from finance to mathematics to marketing, etc. We have to deal with defense problems, with cybersecurity problems, with precautionary risks problem, and we have to be aware of many things. And that's very passionating for me. And we will go through this in order to understand what that means. When we talk about artificial intelligence, we have some images. We think about Terminator, or we have films, movies, we have articles that might be frightening or that might be promising.
Sorry.
We have the reality of things through a big jump in computing capacities. And now a machine is able to beat the best player in many games as a pilot fighter also. And we have geopolitical problems also that are emerging, like this very well-known sentence of Vladimir Putin: artificial intelligence is the future, not only for Russia but for all humankind. And whoever becomes the leader of this sphere will become the ruler of the world. We have also things like this. Google finds that as artificial intelligence gets more advanced, it gets more aggressive. Well, it's very stupid it's a very stupid sentence, and we'll understand why, because artificial intelligence could not be aggressive. So what is to be think about all of this? We can, as Luc Julia did, he wrote a book in order to demonstrate that artificial intelligence is something different than the thing we think. But the title is not very good, I think, because saying that artificial intelligence does not exist is not a way to solve the problem of understanding the topic. And also, there are some things like it seems for me like this fake news that coronavirus does not exist. It is not by saying things that everybody knows as true that we can solve problems. So let's see Madame Irma, as we do when we don't understand anything, and many people look at artificial intelligence like this. It's a black box or something very ununderstandable. We could not understand. Well, we will go now through the topic in order to understand where does it come from and what are the challenges. So what is artificial intelligence first? We can see artificial intelligence in everyday life. For example, if I ask you, what is artificial intelligence for you? What would you say? What must represent artificial intelligence between the three images? Is it a smartphone? Is it a pilot cabin? Or is it Sophia, the first robot who had the Saudian citizenship? Well, for many people, it is Sophia. We can see the hype of such things, and for me, it's very worrisome and appalling to see that robots go to the UN in order to be asked questions about the situation of the world. For example, this you can find on the internet, on the United Nations website, this interesting movie where the deputy chef asks Sophia things about what is her thinking about the future of life, and well, it's no comment. So Sophia is an artificial intelligence in the sense of it has a big amount of computing, but only for one thing, for speaking and facial moves. In a plane, in a cabin, in a pilot cabin, we have no AI or very, very less AI for the reason that we must be on the control of what is done. And in general, there are failures in machines. And failures we have is not due to AI, but to engineers and to people that do not know how to how to manage the commands. And there are many, many commands. And the most representative of AI today is our smartphones. As we can read here, we have in our pocket lots of AI applications. Language processing, computer visions, and so on. So AI is in your pocket everywhere. What is the history of AI? I want to begin with this sentence of Adrian Mayer. Our ability to imagine artificial intelligence goes back to the ancient times. Well, we have many fantasies about artificial intelligence, about the ability of humankind to create life. And this is a big part of the hype we have around AI today. Recent history of the rise of AI. Well, we had the Turing's test. So the purpose of this is to try to guess if you have to talk to a person or to a computer, can you make the difference between them, to go shortly. The birth of AI was in 1956 at Dartmouth College, where the word was created, and many people went in order to create this new science. Artificial intelligence begins with the perceptron, so it was the ancestor of our neural networks today. The purpose was to separate classes. Then we entered AI winters. We had many winters, essentially due to the non-realized promises of AI, and after there was some things around the expert systems who failed because they were done with rules, and today expert systems are totally different. They are done with probabilities. Well, and AI goes in winters for 30 years and wakes up with neural networks and the beginning of the internet that allows people to get more and more data, the rise of the smartphone also. And today we are in a, well, it's common to deal with these technologies. So back to Dartmouth College, the foundation of AI. It's interesting to know how they define it. So AI, as we can read here, is the purpose of AI is to proceed on the basis of the conjecture that every aspect of learning or any other feature of intelligence can in principle be so precisely described that a machine can be made to simulate it. So the purpose of AI is to understand how human brain works and to pass it and to transfer it in a machine. As we can understand, it is not really what AI is today. Today, AI is to try algorithm in order to make something that will look like human thinking. So it's very interesting to go back there. And it is also on the basis of conjecture, and people who do science understand this word. That is something we do not prove. And here are the people, the main people at this conference, and many high-level people. Simon, who has the 2 Nobel Prizes, the Nobel Prizes in economics and the equivalent ACM Turing Award in computing. Well, there were many interesting people there. So from this, what is artificial intelligence? What definition can I give to you in order to be clear when we speak about artificial intelligence? Every people can agree for the word artificial, you know, something produced by humans work and not by nature. And there are many discussions about intelligence. Well, intelligence is the ability to learn, solve problems, but also experiment emotion. There is a part of creativity and the self-awareness. So can we say a machine is intelligent? Well, there are many suppositions around that. Some ones talk about the law of singularity. There is a question of strong AI. A strong AI is an AI that would be able to do any task as a human. But today we are in weak AIs. That means that like each application of your smartphone, a program of AI is able to do one task, only for speech or only for vision, etc. So when a robot speaks, he must say artificial intelligence is science. It is not also but science, like maths, physics, if we go back to the definition. And for it, he's a robot, not an AI. So when we talk about AI, we in general speaks about the devices, but a device is not an AI, it's only a device. And when you hear about artificial intelligence, keep in mind that it is a science. And what you have in your smartphone, for example, is a program done with some artificial intelligence, as we can have some physics when you build engines and so on. So for artificial intelligence, I have 3 things to define it. It's the ability to learn. So we have many kinds of learning, semi-supervised, unsupervised, supervised. That is either the program can learn without any instructions to find dependencies between things, or we can give him a target and he had to find the target as best as possible. It must also be able to represent knowledge. It's a purpose, and it must help us to do inference and reasoning. If you have a machine that you cannot understand the results, what's the interest? So today we hear about AI as deep learning, but AI is a wide domain. And it's wrong to think that AI is only machine learning. AI is also expert systems and many other things, as we will see. So for me, artificial intelligence should not be a black box. Here we talk about how we can use artificial intelligence. It's interesting to have programs, but the purpose is to understand how they work, or at least how they can improve our ability to learn. And for me, artificial intelligence applications should be like this. that is a practical help if we want to reason, to search. We can go further. Many people does not see the difference between traditional programming and machine learning. It's like something new, totally new, arise, and nobody is able to explain what it is. Well, there is nothing under the sun, as we can say, nothing new in the principles. An algorithm, we must know what an algorithm is. It's a list of instructions, and what a program is a way to make them in action. So for an example of algorithm, when you want to make a coffee, well, you have to describe what are the steps, but you should be cautioned about some things. The degree of freedom. For example, when you tell the machine to power hot water, if you do not explain that it should stops, well, it will pour hot water until there is no water to pour. So the part of algorithm is to be very, very precautious on what we write. So algorithm is writing instructions, precise instructions to do something. And when you write, well, you have to share it. So an algorithm is shared in a machine. So a computer, for example, had many languages, and these languages are programs. So you have specialized programs, for example, HTML or Python, etc. There is a specialty of each program to do tasks. For example, traditional programming helps us resolving problems like this. We want to find a word, and we write an algorithm. We put it into a machine with a program, and we have a result, and we can play with. We know the steps. We have described the problem, the phenomena, and we can go on. But machine learning has can ask another question, another type of question. What are the instructions to make the distinctions between a chihuahua or a muffin photo, for example? Can anybody write a program in order to find in a photo a program step by step describing exactly how to do in order to distinguish chihuahuas? Well, it's more difficult. And the way that is done with machine learning to solve this is very interesting. So in the first case, in traditional programming, we know the rules in order, for example, to add numbers. So we have data in entry, we have an algorithm, and we give a program to the machine in order to have an output. For the machine learning problem, the question is that one. We have data, we have an algorithm, we give the machine a program, and there is an output, and the output here is the improvement of the algorithm by itself. When we say this, there is something missing. We introduce outputs in the machines. What are these outputs? Well, they are, for example, all the list of all the photos of chihuahuas we have. Then the machine will learn progressively what they look like, and the algorithm will adjust himself in order to be more and more accurate, in order to find what is the difference between a chihuahua or a muffin. And when the algorithm will be wrong, when the classification will be wrong, you will tell the machine, no, your answer is wrong, you have to correct some parameters in your algorithm in order to be better. So it's a redirection movement. We give data. The data is our photos, for example. We have an algorithm that is predefined, and then the machine, we will let the machine be better and better to improve the algorithm, the program's parameters. So in one case, we give explicit instructions, and but when you want improvement, you have to code again. For example, if you want to not to do an addition but multiplication, well, you have some stuff. On the other case, the system will learn the patterns from data, and the improvement will only require more data. So if you don't have enough data, you understand that your program will not be efficient. And we can combine these both approaches. The question of reliability is very interesting. For example, anybody can create a program or an algorithm that will find 100% of the chihuahuas in the preceding photos, in the preceding pictures. This program is very simple. You have to tell the machine that when it sees a photo, that is a chihuahua. So at the end of the process, you will have all the chihuahuas, but you will also have a lot of wrong photos. And the reliability of artificial intelligence should be very carefully scrutinized in order to be sure that it's efficient. We need patterns in order to improve AI, when you are a human, you give explicit instructions to the machine also. And some questions like kill baby or kill mummy problem is of interest. For example, what is a choice? It is not a machine that will decide. It is a programmer that will give the machine the instruction when it has no possibility to make a choice. So we need to combine machines and human expertise and decision in order to be very, very efficient. So let's going in the world of analytics and understanding what is modeling and reasoning in this world. So as a data scientist, you know this. This is a tableau of Magritte that, and it is written, ceci n'est pas une pipe. This is not a pipe. Why? Well, it's a notion of model here. A model is a simplified representation of the real world. So for a man who has never seen a pip, this is a pip. And it's very useful to understand and how it works, etc. But this is not really a pip. And this is all the job of a statistician or a data scientist or a scientist in general, to work with model. We only work with models, that is with a representation of some aspect of the real world. And the purpose of a model is to be useful. It will always be wrong, but its purpose is to be useful. So the purpose is to explain or to predict. So there is association, correlation. On one side, association answers questions like what is the probability that somebody will buy a product, for example. And causation is another kind of problem. It's about finding things. For example, what are the effects of a vaccine, etc. What are the main drivers? So you want to go further in explanation of things. On one way, you observed, and on the other way, you act on data. And we can think to build our map to another axe, the axe of source of models. The source of models could be theory, pure theory, formulas, etc. For example, it's the way we found physics laws for relativity, etc. And for data, there is data also as a source. And then we have a map, and we can put in this map machine learning. So the question is, where is machine learning in our map? Is this association and theory, or association and data, or causation and theory, or causation and data? Well, the answer is the following. Machine learning answers the question of association, correlation, and needs a lot of data. So what will be the, how can we deal with all the problems? And the right side of the map is a very interesting one. It's causation. While machine learning is going this side slowly, but it cannot do, it will never be able to do causality. Causality is a matter of human. We have to understand problems. We have to ask questions to go further in causality, because we are a specialist of questions like why things happen, how, what to do, who is responsible, etc. We need a domain knowledge, and a machine does not. So if you want to improve machine learning, if you want to improve a program, you have to combine human expertise and computing. So let's explore AI with Bayesian networks. It's my topic. We'll see the two families of AI technologies. So I'm working on Bayesian networks. It is especially done for research and reasoning, as we can read from Stuart Russell, one of the ASEAN Turing Award members. Bayesian networks are as important to AI and machine learning as Boolean circuits are to computer science. And it's very interesting to talk with people, with data scientists who doesn't know many things about Bayesian networks. Well, how does it work? Well, we have an example here. For example, there is a hit and run accident, and the taxis run, and there is a testimony that the taxi was white. So the man come and said, well, I thought that the taxi was white. You are in the jury, what will you decide? Well, we will decide he's okay, he has reason, yeah. If you know that 15% of the taxis are white in the town, will it change your judgment? No. If you think that, if you know that the person who saw the turn accident has a 80% accuracy vision, what will it change in your judgment? We can model it in a Bayesian network like this. You know that in the town there is a certain percentage of taxis, and you know the quality, the vision accuracy of the witness. You enter this in the machine, so you draw a graph for the causal situation, you enter probabilities, and you have the resulting probabilities that shows that in the world of the witness, because of his lack of accuracy, he sees the world with 71% of yellow cabs. That is not 80. And when you ask the system the question, well, what would it be if, what would have been, what is the situation if the witness sees the taxi is white? Well, the system said you should believe that the taxi is not white. Okay, so it's very interesting to that our brain is not good at probabilities. So we need an engine to help us understanding these kind of things. For machine learning, we have deep neural networks. Well, everybody knows about it. It had a ASM Turing Award recently, last year. But the question is, well, it works, but what about understanding? Because it's many layers. You have many layers and many things in these computations, and it's very difficult to understand what is behind, how conclusions are made. As you can see on the right, the first column of photos are correctly classified. You hide random noise. It's not really random, it's chosen. And when you superpose these two pictures, for us as human, it's the same, but for the machine, it's ostrich. And you have things like this. You can hack the cameras and of vehicles in order to thinking that the stop is a speed limit 45, for example. So there's a problem of understanding. Machine learning is a problem of searching. We have a big space to explore in order to find good models. So we have to find heuristics, how to navigate between all the possibilities of the models. Can we be sure? How is it possible to be sure that we found the best one? There is no best one. So, well, it's a job to find this. And we have Bayesian networks that provides, as we saw before, the opportunity to build networks to see how things are in relation and to apply the famous Bayesian formula. This is the result of structured machine learning. So we learn the S&P 500, so the stock market for 3 years. It was 10 years ago, less than 10 years ago. Yes, it is an old example. And you can find here how things are. So it's not a black box. You see how the machines connect things. You can find ecosystems. This is very interesting. And you can find things, relationships you do not know, etc. The size of the bubbles explain what is the importance of information of the company in the system, etc. So it's very, very informative. I will show you this video in order to make you understand what how machine learning works. So I have to connect the sound because Well, hope you understand what machine learning does. Well, machine learning goes in a search space, as I drew before, and it will search into this space the best model. And when it focuses on something, it cannot see the other things around. That is why we are in weak AI today. That is AI that are very specialized in things like only voice, only vision, etc. And the vision of big AI that like a Terminator is not for today. This is why we need intelligence, because our brain can deal with very few data. When you see this at the first time, at the first picture, when if you are asked to guess what are the color of the balls, well, you will say only red, and then you say white, etc. And at the end of the process, you can have an expected or unexpected thing. Your brain is able, with a few samples, to guess things. We can see also this picture. So you will see the relief changing. Our brain is sampling. So, well, how does this work? If you need big data to explain this, it might be difficult. And we can do this with the Bayesian networks very easily. So you can go and talk with an expert who will explain you that a shadow is a result of a relief and light. So you will build the model. Light and shadow gives relief. You will put inside the probabilities, and then you will run the model and find what is the result. You can also work on option of rational and causal inference thanks to this kind of models. Well, I will go quickly on this topic. And Bayesian networks is so a technology that allows also machine learning, but brain mining. You can introduce in your network your knowledge, and you can introduce data in order to build a network. So there is a really continuum between human and machine in order to improve our discernment on decision. And correlation is not causation for observational data, but this is another topic. As you understand now, this is why AI could not save the world, because AI, a certain kind of AI, machine learning, cannot save the world, because it needs more and more data. And when things are new, you have no example to build a model. So in every interesting situations of life is made of a certainty, and things does not repeat indefinitely, as we can see today with the coronavirus pandemic. Machine learning, deep machine learning, neural networks cannot do anything. We have to build models. We have to call for researchers and specialists in order to build other kind of machine learning, like with Bayesian networks, as I saw for the taxi problem, etc., in order to be able to solve problems. So there is a kind of AI techniques for each problem. There is not an AI that has a superpower. This is the thing to have in mind. And well, how to build bridges between people thanks to this technology? For me, AI must be in a continuum, a human-machine continuum. There must not be the machine from one side and the human who must obey the machine on the other side. This is not a way to do. And as we can see on the left part of this slide, well, we can do with Bayesian networks what we do with mind mapping. That is, show people our way of thinking, how we think, and we can share it with other people and discuss and go ahead. And all the problems of ethics in AI, well, are as a consequences of only a view, one vision of what AI should be. But there is not only the GAFAM vision of AI, there are alternatives. Well, we talk about autonomous cars. This is an example of a car that cannot go ahead because we learned it that it should not go when there is a line. And the same question could be asked to us when we are on the internet, because we are more and more closed in our world. We are the algorithm make a kind of containment of our spirits, of our ability to discern how the world is. And if you like a video, I don't know if you like the music, kind of music, of classical music, well, YouTube will give you tons of classical music, but I don't think it will give you a recommendation of a hard rock group, and so on. And it's very dangerous to be in a context we do not discern how it works. There are problems about security. We are going further than AI here, because with 5G, the speed of communication will increase. And AI is combined now with cybersecurity. And well, how to, we are not able today with the speed of transaction to ensure security. How will it be with 5G technologies in every IoTs everywhere? Is it a sustainable way to live? Well, the yellow color you see here is the consumption of your smartphone when you are streaming a video, and the red ones are the energy, the total energy that are needed for you to see that video. Is it reasonable to do that today? Another question around the environment is an application I'm working on, an application of digital seal service on the private blockchain we developed. When you see that one Bitcoin transaction needs 2,000 kilograms of CO2, we can, well, be very interpelled by that. And we developed this digital platform service. And what is a digital seal? Well, it's a tool to ascertain a fact, protect an evidence, claim ownership for intellectual creations. It's on blockchain. You have a QR code there. If you want to scan it, you will see what I put in it for fun. And the cost of a transaction is 0.015 kilogram of CO2. Well, we divide it by 10,000, the cost of a transaction, more than tens. The principle is here. We secure your digital file with geolocalization, etc. We put it on our blockchain, and then you can, if you want, you can share it and with your partners. There is another side of learning the machine. How do you think a machine can know what a kite is, what a person is? There are people that are paid in order to click and to choose these things, like Google bombing, for example, is another way. Well, it's the salary of this person are 0.00001 euros per click. So you can imagine the day these people live. Finally, what is important is our discernment ability, our creativity, our sense of sharing and fairness in order to be aware of all these challenges that artificial intelligence and new technologies in general challenges us. So I started with this question: who are you? We saw, the purpose here is to demystify things. We understand what artificial intelligence is, I hope. It's clear for you now. We had a map. We understood the difference between traditional programming and machine learning. All is programming. We understood what Bayesian networks is and what the difference between association and correlation, and to make things clear. We build, I hope, we want to build bridges between disciplinaries and persons in order to go further to a better world and better interaction between people. And I give you the end of the question: who are you? As I told you, the first images of my presentation was very, for me, instructive in the sense that it shows what is the job of a data scientist like me. It is to unlike things. When you see, what you see is not the reality. It's only the shadow of what somebody wants you to see. And if you are not fair, if you're not honest in what you do, you can show the perspective you want of anything. And the main thing to do is to approach by yourself the things in order to know their own reality. Thank you very much for your attention, and I'm available to answer questions if you have one.